Okay, so in this video, we're going to continue our journey on surface area, and we're going to take a look at the surface area of cylinders. So let's draw out a cylinder. And this is my cylinder here. You might like to think it's like a soft drink can or something. Okay, and we want to calculate the surface area of this cylinder. Well, remember the surface area is the total area on the surface of this shape. So we're going to need the area of this circle here, the area of the circle on the bottom, and then we need the area of the bit that wraps around the entire thing. Okay, so this big bit here, and this wraps around 3D. Okay, so how can we calculate that? Well, let's start off with the area of the two circles. Okay, and remember that this circle on the bottom is going to be the same as the circle on the top. And let's say that these circles have a radius of r. Well, the area of this circle, so circle, the area is equal to pi r squared. Okay, we know that from the area of a circle. And therefore, if we look at the two circles, so the circles, the component, total area is equal to two lots of this, 2 times pi r squared, because we've got one on the top and we've got a circle on the bottom. So this is the circles component of our surface area. So we've got two circles there, 2 times pi r squared. Now we need to take a look at how can we calculate the surface area of this cylindrical bit that wraps around the whole thing. And this is a bit of a tricky one, but if you grab, say, a piece of paper and you wrap it around into a cylinder, this might help you understand what I'm about to explain. So let's say that we chop this cylinder down here, right? So we get a scissors on our cylinder and we chop it there and then we unravel it. When we unravel it, you can imagine that this part here is going to unravel that way, and this part here is going to unravel that way. And what do we end up with? We actually end up with a rectangle. And you can do this as an exercise with just a piece of paper. And we're going to end up with a rectangle if we're looking at this part here that wraps out, okay, that extends out when we chop it up and we open it up. The bit that opens up, that's actually the circumference of the circle. So this bit here is equal to the circumference of our circle, call it C, okay? And of course the height here is just the height of our cylinder. So that's h for the height of the cylinder. So what is the area of this rectangle? Well, we know the area of a rectangle. That's just length times width. So in this case, C times h. So if we take a look at the cylindrical component, the area is equal to circumference times the height. Okay, call it h. And well, the circumference, that's just pi times the diameter of the circle. Okay, we know that from our formulas for area and circumference of circles. Okay, so that's just pi times the diameter. And the diameter is 2 lots of r. Okay, it's 2 lots of the radius. So we can put that in. We can say pi times 2 lots of r times the height. And well, let's simplify that down to just be 2 pi RH. And now the formula for the total area of this entire cylinder is going to be the cylindrical component, that bit in the middle, and then just the 2 circles on the top. So this bit here. So let's add those together and we'll make a formula up the top here that is 2 pi r squared plus 2 pi RH, where we have our radius given here and the height is just the height of our cylinder. That's our h there. So it might be worth trying to watch that again and see where this part here about the rectangle comes in. But it's best demonstrated if you can actually do this with a piece of paper and convince yourself that the circumference, when you open it up, is actually just going to be the width of your rectangle. And the height of the cylinder is going to be the height of your rectangle when we chop this up and unravel it. So let's do an example. Sometimes in a test you may be given this formula, but it's important that you can kind of derive it yourself or at least understand where it comes from. So let's take this down here as the total surface area. And total surface area is sometimes written by TSA for total surface area. So let's draw out a cylinder. Here's my cylinder here. And I'm going to give this cylinder radius of 4 meters. Okay, so it might be a really big industrial cylinder that we're performing reactions in. So 4 meter radius, and let's give it a height of 8 meters. How can we calculate the total surface area? Well, we can just plug this into our equation that we've just derived. Okay, so we've created a general equation for any cylinder, and now for any radius r and for any height h, we can just plug the numbers straight into this. So the total surface area is going to be 2 times pi times the radius of our circle, which is 4 meters, all squared, plus 2 times pi times the radius of our circle, 4 meters, times the height of our cylinder, 8 meters. And if we number crunch this, we get 2 times the 4 squared here. So if we do the 2 times this 4 squared, that's going to be 16 meters squared, because that squared is going to come into our meters. Okay, think about your index laws. Times by pi, plus, and 2 times 4 is 8, times 8 is 16. And if you think here, 2 times 4 is 8, times 8 is 64. And if we think about our meters here, meters times meters gives us meters squared again. We get 64 meters squared times by pi. And you could chuck this straight into a calculator, okay? But if we assume that pi is roughly 3 for ease of this 16 meters squared times, we'll put it in red, 3, that's just an approximation so that we can do this by hand. You could put it into your calculator and get a pretty similar answer, okay, but yours would be more precise. Then 16 times 3 is 48, so we'd get 48 meters squared here, and 64 times by 3 would be 132 meters squared here. And 48 meters squared plus 132 meters squared, that is 180 meters squared. So we have 180 square meters of total surface area on this cylinder. So now that we've derived this equation, okay, all we have to do is, as long as we know the radius of our circle or the height of our cylinder, we can calculate the total surface area by simply putting those numbers into our equation. Okay, let's do one more example. And this time, it's going to be the same process, but just slightly different. So here we have our cylinder. And let's say that I give you the circumference of this cylinder. So I say that the circumference of this cylinder is equal to, let's say it's equal to 18. And 18 centimeters. So it's a small cylinder this time. And then I tell you that the height of this cylinder is equal to, let's say, 10 centimeters. Okay, so the drawing's not to scale, but we've got the circumference of the circle on top of our cylinder is 18 centimeters, and the height of our cylinder is 10 centimeters. Using our formula, which we'll bring this guy down here for us. Okay, how can we calculate this? Well, we need the radius, but if we've got the circumference, we can find the radius. Okay, we know that the circumference of a circle is pi times the diameter, which is 2 pi r. Okay, if you think about the diameter being 2 lots of the radius, we get c is equal to 2 pi r. So all we have to do is divide our circumference, in this case 18, divide it by 2 pi, and we get the radius. Okay, so all I've done there is I've put in this 18 for our circumference, and I've divided both sides by 2 pi to get that radius on its own. And again, if we assume that pi is roughly 3, just for the ease of this calculation, we get 18 over 2 times 3, and I'll do it in red, so the red stands out as a bit of an assumption that we're making, that pi is about 3, is equal to the radius. So the radius here is going to be 3 centimeters. And now that I've found the radius as 3 centimeters, I can put that straight into here like this. radius is 3 centimeters. And now I can just plug it straight into my formula for the total surface area over here. So I get 2 times pi times 3 squared plus 2 times pi times 3 times the height, which is 10. Okay, and if we evaluate this, we get 9 times 2 is 18 pi centimeters squared plus 60 pi centimeters squared. Okay, and we can add those together. Again, if we assume that pi is roughly 3, we get 18 times 3, and that is going to be 54. And 60 times 3 is 180. Add those two up, we get 134 centimeters squared. So this is an example of how we might get given, say, the circumference, and we need to get it back to the radius. Okay, likewise, if we're given the diameter, we can get that back to the radius. If we're given the area of this circle on the top, we can get that back to the radius, all through our relationships that we know about circles. We plug it into our lovely formula here for the total surface area, and bingo, we get our final answer. So hopefully that made a little bit of sense about how we can calculate the total surface area of cylinders and how we can derive the formula for the total surface area of cylinders.